Madam? వైట్ బోర్డ్ ఆప్షన్ అప్పుడేమో కింద ఉండే ఈ ఆప్షన్ తో नीचे Welcome to all. So today in physics we are going to start the other chapter, light. Light. So then what is light? Light is one of the forms of energy which provides a sensation of vision. Light is a form of energy which provides the sensation of vision. According to law of conservation of energy, the energy doesn't have particular form. Energy has so many forms. One of the forms is light. So light is a form of energy which provides the sensation of vision. Without light, nothing we can see. So without light, nothing we can see. So light is a form of energy which provides a sensation of vision. So for visibility of the object, the light should incident on the object and reflected light should reach our retina. Then the image of our retina can be formed on the image, on our retina. So suppose if this marker, how is this marker is visible? The light should incident on the marker and reflect. The reflected light should reach our retina. Now, the image of the marker can be formed on our retina. Therefore, the objects are visible due to reflection of light. Objects are visible due to reflection of light. So, without light, nothing we can see. Therefore, light is a form of energy which provides a sensation of vision. According to law of conservation of energy, the energy doesn't have a particular form. It has so many forms. One of the forms is light. Therefore, light is one of the forms of energy which provides a sensation of vision. Now, sun is known as the natural source of light. Sun is known as the natural source of light. Sun is known as the natural source of light. Sun is known as the natural source of light. Sun is known as natural source of light. Not only natural source of light, but also the natural source of energy. Sun is known as not only the natural source of light, source of light and energy. At the same time, it is also known as natural source of light and natural source of energy. According to law of conservation of energy, the energy doesn't have particular form. Therefore, so many forms energy will be. So light is also one of the forms of energy, which provides the sensation of vision. Now, light is one of the forms of energy. So sun is known as the natural source of light. Sun is known as not only the natural source of light, but also the natural source of energy. Sun is known as not only the natural source of light, but also the natural source of energy. Then why is it known as natural source of energy? Why? Because light gives the sun gives the light. Not only the sun, all the stars are the natural sources of light. Not only the sun, all the stars are the natural sources of light, including the sun. Sun is also a star. All the stars are the natural sources of light. All they are natural sources of light. Stars are the natural sources of light. And sun is known as exclusively not only the natural source of light, but also the natural source of energy. Then why is it known as natural source of energy? Why? Because it gives the energy and also light. What kind of energy it gives? Okay, it is giving the light, it is known as natural source of light. Then what kind of energy it gives? All kinds of energy it gives. Suppose sun, heat energy it gives, light energy it gives, and also for getting the food we are depending on green plants. But green plants are depending on the sun. Green plants are taking the water, minerals, and green plants are taking water, minerals, and some other water, minerals, and salts from their roots, and they're preparing their own food in the presence of the sun, which is known as photosynthesis. By the process of photosynthesis, they are preparing their own food. We human beings, we are depending on green plants. Not only we human beings, all animal beings are depending on green plants. So therefore, green plants, all green plants, they are depending on all animal beings. And we human beings are depending on green plants. And also all animal beings are depending on green plants, whereas green plants are depending on the sun. That's why sun is known as natural source of light and also at the same time natural source of energy. All kinds of energy we are getting from the sun. And we human beings, for green leaves or curries, everything we are depending on green plants. And nuts, cereals, pulses, food grains, fruits, vegetables, roots, and everything we are getting from green plants. But green plants are depending on the sun. That's why sun is known as not only the natural source of light, but also the natural source of energy. And all the stars are the natural source of light, but exclusively the sun is not only the natural source of light, but also the natural source of energy. And also we are depending on sun. So for all kinds of energy. Suppose in India or abroad, how much of then energy we are producing from which source? Energy can be produced from various sources. So the largest quantity of energy that has been produced in India is from coal. But coal, once upon a time, the coal was, they are the fossil fuels, living fossil fuels, coal. So once upon a time, they are the living beings. And like large living beings were there on the earth. Large living beings were there on the earth, like dinosaurs. And also the plants were also very large in size. But due to natural calamities like earthquake or tsunami, all these living beings were buried into the layers of the earth. So, and especially so many theories are there, like large disease because of like very dangerous virus like corona. All these living beings lost their lives. Or earthquake or tsunami, such natural calamities, natural disasters. It was like that. And also, and so many theories are saying, many theories are saying that an asteroid collided with the Earth. Then all the living beings lost their lives on the Earth. These, the large living beings, large animal beings like dinosaurs, will raised up to a few kilometers and again fell on the Earth. So that's why they lost their lives. And also dust particles and all dust will be raised up to few kilometers, some lakhs of kilometers. On the earth, gravitational force is there only up to 3,200 kilometers. Since it has raised to lakhs of kilometers, for sedimentation of these dust particles or coming down these dust particles, it took hundreds of years. But for hundreds of years, all this earth was covered with the dust. That's why no sun rays were penetrated to the earth. No sun rays incident on the earth. Therefore, no sun rays incident on the earth. Therefore, the living beings lost their lives. Plant beings lost their lives due to coldness. All the earth, all the water on the earth was turned into frozen state. It was turned into frozen state. That's why all the living beings and even plant beings lost their lives. So after hundreds of years onwards, again, due to the sedimentation or reaching of these dust particles on the earth, it fell on the living beings. Then after hundreds of years onwards, again surface was getting on the earth. Then due to the hotness or the heat from the sun, the earth was becoming hot. All these living beings turned as a fuel, that is living fossil fuels. And around 53% of energy that has been produced in India from coal. Coal was prepared like this. So, and also the fluids which were separated from these living fossils in the earth were converted as the petroleum products like kerosene, petrol, diesel, etc. And from kerosene, petrol, diesel also we are able to produce the energy, electrical energy. And also the gases which are released as termed as natural gases. What are the major components of natural gases? Methane, ethane, propane, butane. The major content is methane. 75% of the natural gas linked to methane, CH4. And then 10% of natural gases will be composed by ethane. So like this. And from these natural gases also we are able to produce the electrical energy. Therefore, this 53% of energy because of the sun indirectly, all these living beings were turned as a fuel due to the sun. And once upon a time, those living beings lived because of the sun. Therefore, sun, because of the sun only, we are able to produce this coal, the thermal power stations, the energy from thermal power stations. And also second priority, second largest energy that has been produced in India is tidal power energy from water. Around about 14% of energy that has been produced from tidal power stations in India. So obviously these tidal power stations, the energy can be produced. So we are able to store the water in the reservoirs, the rain water. Rain water is harvested in the reservoirs. Now we are able to establish the hydro power station nearby. But this rainwater was because of the sun. Why? Because water evaporates at any temperature. Whenever this water, because of the sun, rise and fall of temperature, more is the temperature because of the sun on the earth, more will the water evaporates from all water sources like oceans, sea, rivers, wells, canals, and all agricultural crop fields, the water can be evaporated. Even from the trees, green plants, the water will be evaporated. Now, in certain season, it will fall as a rain. Therefore, this rainwater is harvested for production of hydro power station, hydro power energy. Like this, directly and solar power energy because of the sun. And also, wind power energy also because of the sun. Winds will blow due to the rise and fall of atmospheric temperature. Therefore, all kinds of directly or indirectly, all kinds of electrical energy that has been produced based on the sun. Therefore, sun is known as not only the natural source of light, but also the natural source of energy. Sun is known as not only the natural source of light, but also the natural source of energy. Then natural source of energy. Then next one is, then what is the distance between sun and earth? Distance between sun and earth. It is 14 crores 95 lakhs 14 crores 95 lakhs 98,500 kilometers. 14 crores 95 lakhs 98,500 kilometers. $95 lakhs 98,500 kilometers. 500 kilometers. So this is also known as approximately 14 crores 95 lakhs 98,000. 98,500 means approximately 1 lakh plus 95 lakhs, 96 lakhs. So 100 lakhs is 1 crore. It is approximately 15 crore kilometers. 15 crore. The question was given in SSC and also group 1, group 2. What is the approximate distance between sun and earth? Approximate distance between sun and earth is 15 crore kilometers. That is 15 crore kilometers. This is also written as 15 crore kilometers means 15 into 10 to the power of 7 kilometers. 15 into 10 to the power of 7 kilometers. 10 to the power of 7 is nothing but 1 crore. So that's why we can also write the same thing can be written as 15 into 10 to the power of, we can also write this thing is also written as 150 into 10 to the power of 6, we can write 10 to the power of 6 kilometers. 10 to the power of 6 is nothing but million. So that is also written as 1 million. And 150, this is 150 million kilometers. 150 million kilometers. 150 million kilometers. This is known as 1 astronomical unit. This is known as 1 astronomical unit. Astronomical unit. One astronomical unit, and that is also written as 1A. 1A. 1 astronomical. This is used for measuring the distance between other universal objects. And it was given what is 1 astronomical unit asked in Group 1, 2, SSC, and some other competitive examinations. The distance between Sun and Earth is considered to be 1 astronomical unit, and which can be used for measuring the distance between other universal objects. For example, what is the distance between Sun and Earth? That is 1 astronomical unit, whatever the distance is. And also, we can also measure what is the distance between Sun and Pluto, Earth and Pluto, and Neptune, Earth and Neptune, various universal objects. We can measure the distance between. If it is approximately 15 crore kilometers, it is 1 unit, 1 astronomical unit. If it double to 2 astronomical units, triple 3 astronomical units. We can do like that. So therefore, the third one is the next one. What is the speed of light? The speed of light. Speed of light. Speed of light can be represented by c. That is, c is equal to, it is represented by c. C is equal to 3 into 10 to the power of 8 meter per second. 3 into 10 to the power of 8 meter per second. That is the speed of light. 3 into 10 to the power of 8 meter per second. Speed of light is 3 into 10 to the power of 8 meter per second. Meter per second. This is the speed of light. So 3 into 10 to the power of 8. So we know that 10 to the power of 8, for converting this meters into kilometers, we should divide by 1000. That is 3 into 1000. 3 into 10 to the power of 8 divided by 1000 is 10 to the power of 5. We can get 10 to the power of 5. That is, now it is in kilometers. So here 10 to the power of 8 meters is divided by 1000. Why? Because 1 kilometer is 1000. For getting the information or the number which is in meters into kilometers, we should divide by 1000. 10 to the power of 8 by 1000 is 10 to the power of 5. 10 to the power of 5 into 3 is, that is 3 lakh kilometers every second. So light travels at the rate of 3 lakh kilometers every second. This is the speed of light. Light travels at the rate of 3 lakhs kilometers every second. This is the speed of light. Now, what is the time taken by sunlight for reaching the Earth? What is the time taken by sunlight for reaching the Earth? The time taken by sunlight for reaching the Earth. Time taken. Taken by sunlight for reaching the Earth. For reaching the Earth. reaching the Earth for the time taken. Time we are going to find out. So that is time taken will be how much? It is, so we know the speed of the light is 3 lakh kilometers per second and distance between sun and earth is approximately 15 kilometers. So we know the relation between time, distance, speed and time is equal to distance by speed. Time is equal to distance by speed. Time is equal to distance by speed. That is d by c. Time is equal to distance by speed. So how much distance? That is 15 crore kilometers. 15 into 10 to the power of 7. That is kilometers. Now, by time taken will be for reaching the Earth. Now, speed of the light is 3 lakh kilometers per second. 3 into 10 to the power of 5 kilometers per second. Here, distance between sun and earth is d is 15 kilometers. Speed of light is 3 lakh kilometers per second. Here, distance is in 15 into 10 to the power of 7 kilometers. 15 kilometers. That is in kilometers. Speed also kilometers per second. And we are going to get the time. Time is in seconds we are going to get. Time we are going to get it in seconds. So therefore, seconds. Seconds we are going to get. Then how many seconds that is? How many seconds we are going to get it? How many seconds? So that is here 3 ones are, we can take here 3 ones are 3, then 3 ones are 3, then 3 fives are 15 we can get here. 3 fives are 15. So that is 3 fives are 15. So here we are going to get here 5. And here 10 square, 10 to the power of 4, 5 and 10 to the power of 7 gets cancelled. We are going to get here 10 to the power of 2. 10 to the power of 2 into 5, 500 seconds, that is 500 seconds. If it is more than 560 seconds, we can convert into meters. We can convert into minutes. 500 divided by 60. So go on, divide by 60. Then 68s are 68s are here. Sixty-eight, we are going to get it 68 of 480. So we can get the remainder 20. 20 is the remainder. Now here we can take a point here, point. Then we can get this will become 200. Then 63 is 180. 180. The remainder we are going to get here is 20 is the remainder. And also we can get one more zero. We can take one more zero can be taken here. Now 63 is 63 is again the name. So that is 8.33 we are going to get it. 8.33 minutes. So that is also written as 8 minutes. Here 20 seconds. 8 minutes 20 seconds is right answer here. 8 minutes 20 seconds. But here we are getting 15 into 10 to the power of 7 now. If you take 14 crores 95 lakhs 98,000, then we will get not 500 seconds. Here 400 seconds. 499 seconds we can get. 499 seconds. 499 seconds we are going. We'll get. 499 seconds. 499 seconds. That is 8 minutes 33 seconds that will be equal. 8 minutes 19 seconds we can get here. Reminder, by dividing this 499, why do we get, why not 500 seconds here? Here for 15 crores we are taking, but exact value is 14 crores 95 lakhs 98,000. That is 500 divided by 60. 500 divided by 60. 500. We should not take here 500, but 499 seconds we should take. 499 seconds we should take. 499 seconds. That 499 seconds should be divided by 60. So 60 8s are 480 by 480. So remainder we get here is 19 seconds. Therefore, the time taken here 8 minutes and 19 seconds. 8 minutes and 19 seconds. This is the time taken by sunlight for reaching the earth. Sunlight for reaching the earth. Then what is light year? We are going to learn about light year. Light year is the distance traveled by light for 1 year. Light years. Light year is nothing but distance traveled by light in 1 year. In 1 year. The distance traveled by light in 1 year. Light travels at the rate of 3 lakhs kilometers every second. Then in 1 year, how much distance it can cover? So 1 minute light travels 3 lakh kilometers. 1 minute 60 into 3 lakhs kilometers it travels. Then 1 hour, how much it travels? So like that. In 1 year without stop, non-stop, the light travels how far distance in 1 year. That distance is known as light year. Then light year is a unit for which physical quantity? Asked in so many quantity examinations. Group 1, Group 2, and sub-inspector of police. It was given. Light year is a unit for distance. It is a unit for distance. Whatever the distance that it can cover in 1 year time is known as light year. So light year is the distance traveled by light in 1 year. Now that's about light year. Now, what is the relation between distance, speed, and time? Light year is nothing but distance. Then how much is 1 light year? Means light travels how much of distance in 1 year? Light travels. We know for getting the distance, that is distance is equal to time into speed of the light. Time, how much time? 1 year time in seconds. We should take time into 1 year time into time. That should be taken in seconds. 1 year time should be taken in seconds. Time should be taken in seconds into speed of light. Speed of light. Then how much is it? It is 365 days. 365 days and 6 hours and 10 seconds. 1 year is nothing but 365 days, 6 hours and 10 seconds. What is 1 year? It is the 1 year is nothing but the time taken by the earth for completing one revolution around the sun. Therefore, it is 365 days, 6 hours and 10 seconds. 24 hours is 1 day, 12 hours is half a day, 6 hours is quarter a day. Therefore, 365.25 we can take here. 365.25. And every day 24 hours. So we are going to convert into that is 24 hours. These many days in 1 year, hours in 1 year. Every day 24 hours, every minute 60 seconds, and every minute is 60 seconds. Every hour is 60 minutes, every minute is 60 seconds. These many seconds in 1 year, the speed of light is 3 into 10 to the power of 8. Now, since it is a unit for distance, this is measured in meters. That means light travels in 1 year this much of distance. Whatever the distance that it can cover in 1 year is known as light year. And by simplification, we can get here that is 9.46 into 10 to the power of 15 meters. So that is also written as 9.46 into 10 to the power of 15 meters is nothing but 10 to the power of 12 kilometers. 10 to the power of 12. 10 to the power of 7, we know 1 crore. 10 to the power of 12 is 1 lakh crores. Light travels at the rate of 9,46,000 crore kilometers in 1 year. 9,46,000 crore kilometers in 1 year. Therefore, this is known as light year, and it is used as astronomical unit. This can be used as an astronomical unit. This can be used as an astronomical unit. What is one astronomical unit? This light year is used as an astronomical unit. Astronomical unit. It is used as astronomical unit. What is one astronomical unit? It is the distance traveled by light in 1 year. Whatever the distance that it can cover in 1 year is known as light year. So light travels, it is used for measuring the distance between other universal objects. Suppose if any planet is there at a distance of this much of distance, 9.46 into 10 to the power of 12 kilometers, this much of distance, then it takes 1 year for reaching that. It takes 1 year. 1 year. Suppose if any planet is from Earth to one planet is there here. From Earth to one planet is there here. Suppose if this is the Earth. On the Earth, if it is any planet is there at a distance of planet P1 is there. Planet P1 is there. Planet P1 is there. Suppose how much distance that is, let it be. Now it takes 1 year, 9.46 into 10 to the power of 12 kilometers. If it is that much of distance, what is the time taken? 1 year from Earth to planet P1. Suppose if the light takes, for sending the light, if you send the light from Earth, suppose it reaches another planet in 1 year. It is taking, that means for light it is taking 1 year for reaching that planet. Then that planet is said to be 1 light year distance from the Earth. 1 light year. What is the distance? 1 light year. Distance is 1 light year, but time taken for that is 1 year. Suppose how far is your home from bus stop? Suppose 5 minutes walkable distance it is, we say usually. That means by walk if we go, it takes that is 5 minutes. Similarly, if any planet is there from the Earth to Earth, suppose for light it takes 5 years. For light it takes 5 years. Then that planet is said to be 5 light years away from the Earth. If for another planet, if it takes 3 years for reaching the Earth light, then the other planet is said to be 3 light years from the Earth. So one more star is there, already planet is there. Suppose for light it takes 10 years from here to that planet, then that planet is 10 light years away from the Earth. Therefore, it is used as an astronomical unit. Then what is a galaxy? We are going to learn about galaxy. What is a galaxy? Galaxy is a group of large number of stars. What is a galaxy? Galaxy is a group of large number of stars. Large number of stars. Group of large number of stars. In each and every galaxy, then how many stars will be there in each and every galaxy? How many stars will be there in each and every galaxy? At an average, 20 number of stars will be number of stars in each galaxy. Average number of stars in each galaxy will be around 10,000 crore stars. 10,000 crore stars will be there in each and every galaxy at an average. 10,000 crores. 10,000 crores at an average. Then what is our galaxy? Our galaxy is Milky Way. Milky Way. In other words, it is also called Milky Way. In other words, it is also called Akash Ganga. Akash Ganga. Milky Way. Then how many stars are there in our galaxy? In our galaxy, about 20,000 crore stars are there. 20,000 crores. This is the number of stars in our galaxy. So, number of stars in our galaxy is about 20,000 crores. Stars in our galaxies, 20,000 crores. How many stars are there in our galaxy? Around 20,000 crore stars are there in our galaxy. Therefore, our galaxy is not visible properly. Our galaxy is not visible to us. So only 1/5 of our galaxy is visible. So why? Because of our full galaxy is not visible to us. Why? Because all these galaxies intermingled, interfered one into the other, penetrated one into the other. Therefore, our galaxy is visible. 1/5 of our galaxy or 20% of our galaxy is only visible. Remaining 4/5 galaxies are not visible to us. Remaining 4 parts out of 5 parts not visible. That is 80% is not visible to us. Our galaxy is visible, only 20% of our galaxy is visible. Remaining 80% is not visible. Remaining 80% is not visible to us. Only 20% of our galaxy is visible. Remaining 80% is not visible. Why? Because these galaxies interfered or penetrated one into the other. Then, how many galaxies are there in the universe? How many galaxies are there in the universe? The number of galaxies in the universe. Number of galaxies in the universe. Universe is expected to be, number of galaxies in the universe is expected to be about 53 billion. 53 billion galaxies are there. 53 billion. We know that 1 billion is 1,000 millions. Therefore, 53,000 galaxies are there. 53,000 million galaxies are there. 53,000 million galaxies are there. Million galaxies are there. That is also written as 5,300 crores. 5,300 crores. These many galaxies are expected to be there in the universe. 53 billion or 53,000 million or 5,300 crores of galaxies are expected to be found in the universe. Then, what is the total number of stars in the universe? The total number of stars in the universe. Number of stars in the universe. Universe is expected to be how much? So 5,300 crore stars, 5,300 crore galaxies, into each and every galaxy, 10,000 crore stars are there. In each and every galaxy, 10,000 crores. Then what is the number of stars in each galaxy? That is 5,300 into 1 crore is 10 to the power of 7 into now 10,000 crores. 10,000 into 10 to the power of 7. And these many, and 10 to the power of 7 into 10 to the power of 7 is 10 to the power of 4, 10 to the power of 14. And this is 53 into 10 to the power of 20. 53 into 10 to the power of 20. This is the number of stars in the universe. The total number of stars in the universe is this much. The total number of stars in the universe is this much. Therefore, all this is universe is formed. All this together can, the universe can be composed. Universe. And all this universe is expected to be in the shape of, all this universe is expected to be in the shape of this thing. All this universe is expected to be in the form of spherical shape. Spherical shape. This is the universe. This is the universe. Is expected to be in spherical shape, almost all spherical shape. Then what is the diameter of the universe is expected to be? The diameter of the universe is expected to be, it is diameter of the universe is expected to be this much. Diameter of the universe is expected to be diameter of the universe is approximately expected to be diameter d is equal to d is equal to diameter is equal to diameter of the universe is expected to be that is 98 million light years. Million light years. 98 million light years. The diameter of the universe is expected to be. From this end to that end, diameter of the universe T is equal to, is expected to be 98 million light years. Light years. So that is 980 million light years, not 98, 980 million light years. That is 980 million light years. 980. That is also equal to 10 million is 1 crore. That's for, therefore, 98 crore million, 98 crore light years. That is light years. Means if we send the light from this end to that end, if the universe is in spherical shape, it takes 98 crore years for reaching from one end to the other. For reaching from one end to the other, it takes 98 crore years. That is about the, because of this reason, we know only 4% regarding the universe. We don't know much about the universe. Only something we know about the universe. Only little thing about the universe we know. Even though today we are using 4G technology, 4G mobile technology, and 4% only we know. Yet to be known 96%. Yet to be known 96%, we know only 4%. Only 4%. Why do we know only 4%? Why? Because this universe is very, very large universe. So diameter is 98 crore years. If you send the light from one end to the other for reaching through the diameter, it takes 98 crore years, not even 98 years, 98 crore years. And that is for light. Even though light travels at the rate of 3 lakh kilometers every second, it takes 98 crore years. It's taking 98 crore years means that much of distance between this, that much of distance, that much of far away from them between these. So that is about our universe. Now, suppose what is the nearest star to the Earth? Sun is the nearest star to the Earth. Then, what is the nearest star after the nearest star to the Earth? Is Sun. Nearest star. Our star to the Earth is Sun. That is. Then, nearest star to the Sun is nearest star to the Earth is Sun. That is. Sun. That is. Sun is known as Sun. Then after the Sun, what is the nearest star? Nearest after Sun. Nearest star after the Sun. Star after the Sun. Nearest star after the Sun. Nearest star after the Sun is, that is nearest star after the Sun. Sun is nearest star and it is Alpha Centauri. Alpha Centauri is the nearest star to the Sun. After the Sun, first one is Alpha Centauri. Centauri, Alpha Centauri. Then after Alpha Centauri, the nearest star. Actually, first one is Sun is the nearest star. Sun itself is the nearest star. Sun is the nearest star, but after the Sun, it is the nearest star after the Sun is Alpha Centauri. Then after Alpha Centauri, then after Alpha Centauri, then it is Beta Centauri. It is Beta Centauri. Actually, after the Sun, that is. It is Beta Centauri. Beta Centauri. Then it is Gamma Centauri. Gamma Centauri. Then after Gamma Centauri, it is Proxima Centauri. Fourth one is Proxima Centauri. Actually, nearest star is Sun. Sun itself is the nearest star. Suppose in the examination, if it is given, what is the nearest star to the Earth after the Sun? After the Sun, it is Alpha Centauri. Then after Alpha Centauri, Beta Centauri, then Gamma Centauri. If you refer the previous books, previous old GK books, you find the answer Proxima Centauri is the answer we find. But Proxima Centauri is not the correct one. So, but then afterwards, the scientists discovered 3 more stars which are nearer than Proxima Centauri. Recently, they discovered. So, that is Alpha, Beta, and Gamma Centauris are nearer than Proxima Centauri. Therefore, so far the nearest stars are the Alpha Centauri. Nearest stars after the Sun is Alpha Centauri, then Beta Centauri, then afterwards Gamma Centauri. Then Gamma Centauri. Then what is the brightest star? Let us learn about brightest star. Brightest star. Brightest star. Brightest star is, it is Sirius. Sirius. Sirius is the brightest star. Sirius is the brightest star. Then after Sirius, then what is the largest star? Largest star is UV spooling. UV spooling. UV spooling. UV spooling is the largest star. Then this is about the light, and in general, the materials are two types. Types of materials. Materials are two types. Are two types. First one is transparent materials, and second one is opaque materials. What are transparent materials? Those which can allow the light to pass through them are known as transparent materials, which can allow the light to pass through them. The materials which can allow the light to pass through them are known as transparent materials. Example for transparent materials are glass, water, etc. Glass is an example for transparent material, water and air and all the gases. Air, all these are the transparent materials. Then second one is opaque materials. What are opaque materials? The materials, those which allow the light to pass through the bananas, transparent materials. Then what are opaque materials? The materials which do not allow the light to pass through them are known as opaque materials. Example like opaque materials, plastic, rubber, wood, human body, stone, etc. Stone and human body. All they won't allow the light to pass through them. So they are known as opaque materials. Now, let us learn the properties of the light. Properties of light. Okay, let me take a small break. Just a minute. The confusion are relevant. So, ఆ తర్వాత బస్ ఆఫ్ బ్యాంక్ బస్ ఆఫ్ బ్యాంక్ ప్లస్ పట్టాదారు పాస్ ఈ నాలుగు పేరు ఎందుకంటే వాళ్ళు లోకల్ నాలుగు లక్షలు చూడాలి అంటే మన కార్యదర్శి కాబట్టి రెసిడెన్సీ మా మన కలిసి వచ్చిన మా అన్నయ్య కూడా క్లాసులో నేను చెప్తే రాస్తాను కావాలంటే ఆధార్ కార్డును ఓటర్ ఐడి కార్డు ప్లస్ బ్యాంక్ బస్ బ్యాంకింగ్ ప్లస్ ఇప్పుడు Okay, welcome back. Welcome back. Let us continue the chapter light. Now let us learn about the properties of light. Properties of light. Properties of light. Then what is the first one is rectilinear propagation of light. Rectilinear propagation. What is rectilinear propagation of light? The property by which the light always travels a straight line from the source of the light. The light always travels a straight line from the source of the light. This property is known as the rectilinear propagation of light. So the property by which the light always travels a straight line from the source of the light is known as the rectilinear propagation of light. Light always travels a straight line from the source of the light. This property is known as the rectilinear propagation of light. The light always travels a straight line from the source of the light. This property is known as the rectilinear propagation of light. And due to rectilinear propagation of light, the shadows are formed. The shadows are formed. Shadow. And usually shadows are formed usually opposite to the direction of the source of the light. Suppose in the night, let us take a torchlight. Let us focus the torchlight onto our hand. We focus the torchlight onto our hand, then shadow of our hand will be formed on the wall. So shadow will be always formed opposite to the direction of the source of the light. If this is the torchlight and human object, and its shadow will form the other side. Similarly, in the morning, if we stand up in the ground, our shadow is formed in the west side. Sun will be in the east, our shadow will be formed on the west. Only shadows of opaque objects are formed, but not the shadows of transparent objects. For example, shadow of water cannot be formed, shadow of air, shadow of water cannot be formed. Shadow of glass is not formed. Only shadows of opaque objects only can be formed. Shadows of transparent materials cannot be formed. And shadow always formed opposite the direction of the source of the light. And in a shadow, there will be two regions usually. In a shadow, there will be two portions. Two portions. The shadow consists of two portions. So first one is umbra, the other one is penumbra. Umbra and penumbra. First one is umbra. And second one is penumbra. Umbra and penumbra. So umbra is the dark shaded portion which is in the middle of the shadow, and it will measure in percentage. So, and penumbra is the light shaded portion will be found around the umbra, about 5 to 10%. And umbra will be 90 to 95% of the shadow will be umbra, that is dark shaded portion which will be in the middle, and it is always major in percentage, 90 to 95%. And penumbra will be found around the penumbra, 5 to 10%, minor. Light shaded portion will be there. Like this, due to rectilinear propagation of light, the shadows are formed. And second one is due to rectilinear propagation of light. First one, the shadows are formed. This is first one is shadows are formed, and second one is eclipses are formed. Second one, eclipses. Usually we see eclipses, that is solar eclipse and lunar eclipse we find. First one is solar eclipse, is formed due to rectilinear propagation of light. And second one is lunar eclipse. Solar eclipse and lunar eclipse. Usually solar eclipse can be formed on, the full new moon day. It is formed on the new moon day. On new moon day, whenever the sun, the earth and moon are on the same straight line. Sun, earth and moon are on the same straight line. Then, so whenever the sun, moon and earth are on same straight line here. Here is the sun. And in the middle, moon will be there. And here, earth will be there. The light incidenting from the sun first incidents on the moon. Moon is the opaque object. Then the shadow of the moon will be formed on the earth. Then at that time, if we are in Umbra, in the shadow of the moon, so the light emerged out of the sun. Because of the light from the sun, which is incidentally on the moon, the shadow of the moon will be formed on the earth. Therefore, in that shadow, there will be two portions. One is Umbra, the other is penumbra. So, therefore, if hold Umbra and penumbra. If we are in Umbra at that time, then for us, no part of the sun is visible to us. Then at that time, if we are in penumbra, that is light shaded portion on the earth, then for us the sun partially disappears. If we are in Umbra, no part of the sun is visible. The sun completely disappears. That is known as complete solar eclipse. Otherwise, if we are in penumbra, for us some part of the sun disappears or some part appears. Only some part appears or some part disappears. This is known as partial solar eclipse. If it is formed, it can be on new moon day. Solar eclipse will be formed on new moon day. That is due to rectilinear propagation of light. Now, how does the lunar eclipse takes place? Lunar eclipse is formed in general on full moon day. It can take place on full moon day. Usually it is on full moon day. Whereas solar eclipse on new moon day, it can take place on new moon day. And lunar eclipse will be taking place on full moon day. On full moon day, when the sun, the earth and moon are on the same straight line, earth and moon are on the same straight line. The light which is emerged out from the sun first incidents on the earth. First incidents on the earth, that is sun. Then the light which is emerged out from the sun first incidents on the earth. Since earth is the opaque object, its shadow will be formed on the moon. Since in that shadow there will be two portions, Umbra and penumbra. At that time, whole Umbra of the earth can cover on the moon. For us, no part of the moon is visible to us. That is known as complete lunar eclipse. If whole Umbra of the earth can cover the moon, for us, no part of the moon is visible. Then otherwise, if some part of the Umbra and remaining part of penumbra can cover the moon, then for us, only some part of the moon is visible. So that is known as partial lunar eclipse. If full part of the moon disappears or not visible, then it is known as complete lunar eclipse. If it is formed, it is on full moon day, and that is due to rectilinear propagation of light. Based on which property of light the eclipses are formed. So based on that is rectilinear propagation of light, the eclipses are formed, either lunar or solar eclipses are formed. Now we are learning about the properties of the light. Now let us learn about properties of the light. Properties of light. Now second one is reflection of light. Reflection of light. What is reflection? The property by which the ray of light gets back in the same medium through which it is passing is known as reflection of light. The property by which the ray of light gets back in the same medium through which the light is passing is known as reflection of light. Suppose if you switch on the light From tube light, it travels to air, incidents on the wall, then reflected. Then the reflected ray gets back into the same medium. Here, ray of light is passing through the air, incidenting on the opposite wall, and reflected from the wall back into the same medium. Here, light is passing through air, getting back to the air. It is not passing through the opposite wall. That is said to be reflection. The property by which the ray of light gets back into the same medium through which it is passing is known as reflection of light. Through which it is passing is known as reflection of light. So that is about reflection. And due to reflection of light, and light can reflect only from opaque objects, but light will not reflect from transparent materials. Light reflects only from opaque objects. It can reflect only from opaque objects, but it will not reflect from transparent objects. That's why opaque objects are only visible clearly. Transparent objects are not visible clearly, since the light will not reflect from them. Now, applications. Now, applications of reflection of light. What are the incidents that are going on happening based on reflection of light in our daily life? That is applications. Applications. Applications number one. Applications. Number one. The objects are visible due to reflection of light. Visible due to reflection of light. Due to reflection of light. Based on which property of light the objects are visible. Suppose how is the person is visible? The light should incident on the person, reflected. Reflected light should reach our retina. Then the image of the person is formed on our retina. Then only the objects are visible. Otherwise, the objects are not visible. Therefore, objects are visible due to reflection of light. Since there is therefore, light can reflect only from opaque objects. That's why opaque objects are only visible clearly. So, opaque objects are only visible clearly. Since the light will not reflect from transparent materials, therefore transparent materials are not visible. Light reflects only from opaque objects. Therefore, opaque objects are visible clearly. Since the light will not reflect from transparent materials, therefore, transparent materials are not visible clearly. Suppose light will not reflect from glass. That's why glass is not visible clearly. Air is not visible clearly. Sometimes even water is also not visible clearly because of no reflection of light. Light will not reflect from opaque, transparent material. That's why transparent materials are not visible clearly. So that is about. Then third one is since the light reflects only from opaque objects are. Then for astronauts, the sky is visible dark. The objects in the dark are not visible. Fourth one. Objects in the dark are not visible due to no reflection of light. Objects will be there only, and but they are not visible. Not visible because of no reflection of light. So, and for astronauts, the sky is visible black for astronauts. For astronauts, the sky is visible dark. Sky is visible dark or black due to no reflection of light. Whenever they are traveling in the spaceship, if they look out, everything is seen black. Nothing is visible for them properly. So why? Because no air, no medium in the space. That's why nothing is visible for them. They look out, nothing is visible for them. So whenever they are traveling, why? Because light will not reflect from space. That's why everything it seems to be dark. Everything seems to be dark. Then the planets and natural satellites are visible due to reflection of light. Planets or natural satellites are visible due to reflection of light. Natural satellites are visible due to reflection of light. Satellites. For us, our moon is visible. Even though moon is not a self-luminous object, the moon is visible to us. So why? Because even though moon is not visible to us, moon is not visible to us due to no reflection of light. Here is the earth. Then the light incident from the sun first incidents on the moon and the earth. Then for these people, first half of the people, first half of the people here, first half of the people, it is visible. But the next half of the people, darkness. But whenever since the moon is revolving around the sun, this is the earth. And if here is the sun, and here is the moon, and here it is earth, and here this is the sun. The light incidenting from the earth first incidents on the light incidenting from the sun first incidents on the earth. And for first half of the people, for these people, daytime, sun is visible. For these people, sun is not visible. Since the earth is revolving around the moon, the light incidents on the sun. The sunlight incidents on the moon first of all. It incidents on the moon. It incidents on the moon. And the light will be reflected from the moon. The reflected light reaches the earth. And for these people, the moon appears to be shining. So the moon is not a self-luminous object. Therefore, it is visible due to reflection of light. The light from the sun or other stars will incident on the moon and reflected light will reach the earth. Therefore, the moon is visible to us shining. And if we go on to the moon also, our earth also appears to be shining due to reflection of light. The light incidenting on the earth from the sun will be reflected. If we are on the moon, then our earth also appears to be shining. For us, almost all the planets are visible due to reflection of light. Planets and natural satellites are not self-luminous objects, but whenever the light incidents on them and reflected, because of the reflection of light, all those objects are visible due to reflection of light. Planets and natural satellites are visible due to reflection of light. And images are formed due to reflection of light. Seventh one is images are formed due to reflection of light. Due to reflection of light. Suppose if we stand up in front of the mirror, the light will incident on the person. If we stand up, we are the object. Ourselves, the light will incident on our body and reflected. This reflected light will be reflected from the opposite mirror. Then our image can be formed in that mirror. The light which is incidenting on the person will be reflected, and this reflected light will be reflected from the mirror. Then our image can be formed. So, based on which property of light the images are formed due to reflection of light. Usually, we watch the images in mirrors and water. Mirrors and water. That is about reflection of light. Reflection of light. Reflection of light. Now, similarly, we watch the images in mirror and water. Then periscope is a device which works based on reflection of light. Periscope is a device which works based on reflection of light. Periscope will be usually, it will be in Z shape. Periscope will be in Z shape. In Z shape. It will be in general in Z shape. Will be in Z shape. And it will be in general in Z shape. And it will be in Z shape. Z shape. And here one mirror will be here, two mirrors will be there. Two mirrors will be there like this. One mirror like this, and one more mirror will be like this. And like this. If any person is there outside, this will come up. This is, and if any person is there outside here, like this, the light incidentally on the person will be reflected from that person. Then the image of that person will be found on the mirror. If this is the person, then light incidentally on the person will be reflected. Therefore, the reflected light reaches. So then the image will be found here. Image will be found here. So that is the image can be found. So this is periscope is a device which works based on reflection of light. Periscope, which works based on reflection. Now, properties of the images found in mirror. Let us know the properties of the images found in mirror. Properties of the images found in mirrors. So in general, we use three kinds of mirrors. We use three kinds of mirrors. First one is plane mirror. Plane mirror. So in plane mirror, what is that? Suppose we stand up in front of the mirror, our face is known as image, object, and whatever the image is seen in the mirror is known as object. Is known as image, sorry. So if you stand up in front of the mirror, ourselves we are considered as object. Whatever the image is that is seen in the mirror is known as image. Here, image size is equal to object size. Number one, image size is equal to object size. Image size is equal to object size. Is equal to object size. Suppose we stand up in front of the mirror, whatever our image, our face will be there, that much of image will be seen in the mirror. That much of image will be seen in the mirror. So whatever our face size, that much of will be visible. Whatever our body size, same size will be visible. That is image size equal to object size, and it is only for plane mirrors. Usually the mirrors will be three types: plane mirror and plane mirrors and concave mirror and convex mirrors. Concave and convex mirrors are known as spherical mirrors. And second one is image distance is equal to object distance. Image distance is equal to object distance. Suppose if we stand up in front of the mirror, then our image is also seen same distance in the mirror. Suppose we stand up 1 yard away from the mirror. The image in the mirror is also seen 1 yard. The distance between that person and mirror is known as object image distance. And the distance between the mirror and ourselves is known as object distance. That is, image distance is equal to object distance. And third one is both the image and object will move in opposite direction to each other. Image and object will move. Object will move in opposite direction to each other. Opposite direction to each other. Opposite direction. Suppose we, by standing in front of the mirror, walk towards the mirror, the image also approaches us, comes in opposite direction to us. So we feel that mirror is imitating us. Both the, if this is the mirror, this is the object, this is the mirror. If image formed in the mirror, whenever we move towards the mirror, this is the object. So whenever we are moving towards the mirror, the image also approaches us. Both the image and object will move in opposite direction to each other. Then they are laterally inverted. These images are laterally inverted. Fourth one. Laterally inverted. That means it appears left side right or right side left. Left side right or right side left. Suppose we walk with the right hand, it is visible like left hand. Both. So that's all. Then what is the minimum size of the mirror required? The minimum size of the mirror required is at least minimum size of the mirror required. Size of mirror required for appearing complete images, at least half of the size of object. Half of size of object. The minimum size of the mirror required for appearing complete images, at least half of the size of the object. So the minimum size of the mirror required for appearing complete images, at least half of the size of the object. So suppose a 6 feet tall person is there, for visibility of his full image, minimum size of the mirror required is 3 feet. Suppose 1 feet object is there, for visibility of this 1 feet object, the minimum size of the mirror required is half feet. Therefore, the minimum size of the mirror required for appearing complete images, at least half of the size of the object. This question was given in so many competitive examinations. What is the minimum size of the mirror required for appearing complete image? The minimum size of the mirror required for appearing complete image is at least half of the size of the object. The next one is, and these images are not the real images. They are virtual images. The images found in plane mirrors are virtual images. Virtual images. Virtual means it's not possible to take. Virtual images are non-real images. So they are not caught on the screen. Suppose if you try to take the photograph of yourself by standing in front of the mirror, stand up in front of the mirror, then try to take yourself the photo. Try to take your image. Take the photo of the image. Photo of the image formed in the mirror. You can't. So why? Because it's not possible to take the photograph of the image formed in the mirror. Therefore, these images are known as non-real images or virtual images. Then why can't we take the photography whenever, suppose if you give the snap, whenever the light incident, the light from the snap, from the camera, whenever the snap incident, flash incidents on the image will be erased out. That's why it's not possible to take the photograph of the image formed in the mirror. Condition is that you should take flash camera. By using flash camera, we can't take the photograph of the image formed in the mirror. That's why it is known as non-real images or virtual image, pseudo image, non-real. It is known as non-real or pseudo image or virtual image. Non-real. It is also called non-real. Also called pseudo image. Pseudo image. Non-real image or pseudo image. non-real or pseudo image. Then these are the images formed in the mirrors. Images formed. Then convex mirror, second one. Properties of the images formed in convex mirror. Convex mirror is a spherical mirror. And in this, suppose the automobiles, side mirror in the automobiles will be convex mirror. Here, if you watch our face in the mirror, our image will be seen smaller in size. Image size will be less than object size. Size of image will be less than the object size. Suppose whenever we stand up in front of the mirror, then our image will be seen very less. Therefore, image size will be less than the object size here. In convex mirror, image size will be less than object size. Image size will be less than the object size in convex mirror. Suppose, and also here, image distance will be more than object distance. More than object distance. So, suppose we are going on a bike. Whenever we are going on the bike, suppose we heard a horn is heard from backside. We don't need to look back now, just we can watch here. Suppose a car is seen here. How does the car is seen? The car is seen smaller in size. Whatever is visible in the mirror is image, and actual car is object. So, since the car is seen in smaller in size, we feel it is farther. Means the car looks very farther, very far away from us, large distance from us. But luckily, if you look back, the car will be seen here only. The distance between car and our mirror is known as object distance. Whatever the distance that is seen within the mirror is known as image distance. Therefore, image distance will be less than the object distance. Image distance is less than the object distance. That's why a caution is written on the mirror. Caution. On any mirror, caution is written. Caution. What is the caution? The objects in the mirror are closer than they appear. The objects in the mirror are closer than they appear. Means whatever the objects are visible in the mirror are very closer to you, closer than they are visible here. That's why that caution is given. Actually, they are very near, so it appears to be farther. Object distance appears to be farther. Therefore, that caution is given. Then, what are the properties of images formed in? Properties of images formed in concave mirror. Third one is concave mirror. Concave mirror. The properties of the images in concave mirror, and in convex mirror, image distance is less than object distance. No, here image size is less than object size. No, there image size will be more than object size, and also image distance will be less than object distance. Let me take a small break, please. So therefore, here in convex mirror, concave mirror, since in convex mirror image size is less than object size, and here in concave mirror image size will be more than object size. And similarly, in convex mirror, image distance is more than object distance. So here image distance will be less than object distance. And where do we use this concave mirror? Convex mirror can be used as rear view mirror. It is used as rear view mirror. Concave mirror. Convex mirror is used as rear view mirror. Rear view mirror. Whereas concave mirror is used as this use of concave mirror. Use concave mirror. Use of concave mirror. It is used as concave mirror is used as, and it is used in headlights in automobiles. Headlights in automobiles. And also it can be used in torch light. Headlights in automobiles, also torch light it can be used in. And also dentists and eye specialists can use it. Dentists and eye specialists can use it. Now, properties of the images formed in the mirror. Then, number of images formed in between two plane mirrors. Number of images formed in between two plane mirrors. Suppose we stand up, if you go to any barber shop, then if we stand up in front of the mirror, our image will be formed in the mirror. Then since back side one more mirror will be there, our image will be reflected from the back mirror, and also one more image can be seen in the front mirror, and the second image is seen. That second image will be little bit above, a little bit back, little bit smaller size, and also the second image will be reflected from the rear mirror. Again, third image can be formed. Then how many images are formed? It depends on the angle between the mirrors. Based on angle between the mirrors, the images are formed. Angle between the mirrors, that is. Angle between mirrors. And number of images formed. Number of images formed is 360 by theta minus 1. Now, suppose if the angle between the mirrors is 180 degrees, then how many images are formed? 180 degrees. Then how many images are formed? That is 360 by 180 minus 1. So this 360 is divided by 360 ones are 360 twos are. 2 minus 1 is, that is 2 minus 1 is 1 image can be formed. If the angle between mirrors is 180 degrees, only one image can be seen. Suppose, what is the meaning of 180 degrees? If these two are the mirrors, this is 90 degrees, this is 180 degrees. 180 degrees like this. They are very side by side like this. Just to be on same straight line. Two mirrors. This is one mirror, this is another mirror. On same straight line. Angle between these two is 180 degrees. It may be one adjacent to each other or away from each other. This is also 180, this is also 180, this is also 180. Suppose if we stand up in front of these two mirrors, then part of the image can be formed in the one mirror, and the remaining part will be other mirror. Or if they are away from each other also, this is also 180. Then if you stand up in front of this mirror, our image can be formed here. No image is seen here. Only one image is seen. Or else if you stand up in front of this mirror, our image is seen here. No image in there. Therefore, on the whole, only one image can be formed if the angle between two mirrors is 180 degrees. Suppose if second one is, if it is 90 degrees, how many images are formed? That is 360 by 90 minus 1. That is 91s or 94s are 4 minus 1. 4 minus 1 is 3 images are formed. The angle between mirrors is. And if the angle between mirrors is then 45 degrees, how many images are formed? That is 360 by 45 we can take minus 1. So 45 ones are 45 eights are. Then 8 minus 1. Then 7 images are formed. So we can find out for any angle. Suppose if it is 1 degree, always 1 degree. Then divide 360 by always by angle between the mirrors, 1. That is nothing but 360 by 1 minus 1, that is minus 1. 360 by 1 is 360, minus 1 is 359 images are formed. 359 images are formed. Therefore, 359 images are formed. Then suppose if the angle between mirrors is 0 degrees, how many images can be formed? 0 degrees. Then it is 360 by 0 minus 1. Always 0 by something is 0, but something by 0 is always infinite. Infinite number of images are formed if the angle between mirrors is 0 degrees. Why 360 by 0 is infinite? Why? Because let us divide 360 by 0. How can we it is 0? Then 360 by 0. Let us take 360 divided by then 0. 0 ones are 0. Remainder is 0 ones are remainder is 0. Then remainder 3 0 0 ones are 0. Remainder is 360. Then 0 twos are also 0. Remainder will be 360. Remainder will be 360. That is 360. And 0 hundreds also even 0. Hundreds also 0. That is 0. That is 360 and so on like that. And so on like that. Therefore, 0. Therefore, infinite number of images are formed. The angle between two mirrors is 0 degrees. Then infinite number of images are formed. Infinite number of images are formed in two mirrors. So, how will be the position of the mirror if the angle is 0 degrees? So, two mirrors should be face opposite each other. Then, if you stand up in front of the mirror, then infinite number of images are formed. Suppose if you go to the cloth room, dressing room, trial room, if you buy the dress, textile showroom, you go enter into the trial room or dressing room. So we buy pant or shirt, whether fitting is right or not. So there, four mirrors will be there in that. We don't require four mirrors. Even 2, 3, 4 mirrors also visible. 2 is more than enough. One front mirror, one back mirror. So infinite number of images are found. If you watch, infinite number of images are found. Now we are learning about properties of light. The next property of light is dispersion of light. Dispersion of light. Next property. Dispersion of light. What is dispersion? Whenever the light passes through any denser medium, then the property by which the ray of light is dispersed into various colored spectra, then it is known as dispersion of light. The property by which whenever the light passes through any denser medium, then the property by which the light is dispersed into various colored spectra, dispersed into various colored spectrum. Suppose if you pass the light through the prism is made up of glass. Actually, it should pass like this, but it won't pass. It won't pass, but it can be dispersed. It can be dispersed. Various colored spectrum. Dispersed into various colored spectrum. 7 colored spectrum it is dispersed into. This is known as Vibjar, namely the white light can be dispersed into various colored spectrum, namely Vibjar. This property is known Vibjar, Vibgyr. It can be dispersed into various colored spectrum, namely Vibjar. White light is dispersed into Vibgy. This is known as dispersion of light. Here, why does the light disperses with various color whenever it is passed through the denser medium like prism? Why? Because white light doesn't have particular wavelength, it has so many wavelengths. White light has 7 wavelengths. Therefore, it is dispersed into various colors. Here, violet has a minimum wavelength. Its wavelength of violet will be 0.4 micrometers. Whereas for red will be, it is 0.7 micrometers. Therefore, and wavelength can be increased from violet to red. So, which of the following colors has least wavelength or highest wavelength? It is given in the examination. Vibjar, while in Vibjar, violet has least wavelength, red has largest wavelength, and it increases from smallest to highest. It is in the ascending order of the wavelength. And also, next point we should remember that Vibjar you should full form and spelling you should remember Vibgyr stands for violet, indigo, blue, green, yellow, orange, red. And after Vibjar, the least wavelength is indigo, means increased, then blue, then green, then yellow, then orange, then red. So in Vibjar, so violet has least wavelength, whereas red has largest wavelength. And it is in the ascending order of the wavelength from violet to red. Okay, so this is the end of the chapter, and next video let us start the other topic. Okay, thank you.